Okay, students, I am thinking that you have already completed induction motors. So now I am going to tell you alternators. So totally our fourth chapter contains induction motors, synchronous motors, and alternators. So coming to alternator, this is also known as AC generator. So AC generator means already we have studied about DC generator. So in DC generator, you have studied that how a DC generator is worked and principle of operation of a DC generator. So the generator means you have already know that which converts mechanical energy to electrical energy is called a generator. So which generates DC is known as DC generator. The electrical energy when it is generated as AC then it is known as alternator or AC generator. It is also known as synchronous generator. Now I am going to tell you about these alternators. So in this topic, we'll study about what is an alternator, types of alternators, working principle, construction and operation of an alternator. So coming to the introduction of an alternator, I have already told you that any generator has the input energy which we are giving is called mechanical energy. So a generator converts mechanical energy to electrical energy. So here in this diagram, you can see that there is a prime mover. So this prime mover is giving mechanical energy to the alternator. Hence, the mechanical energy is converted to electrical energy as shown in the diagram along with losses. Now, you can understand that alternator is a machine which converts mechanical energy to electrical energy. So, for providing mechanical energy, there are prime movers. They can use diesel engine, steam engine, small petroleum engine, anything as a prime mover. The efficiency of the alternator is also mentioned here. Output power by input power into 100 is not the efficiency. Now coming to what is the definition of an alternator. An alternator is a electrical generator, I have already told you, which converts mechanical energy to electrical energy in the form of alternating current. So all these alternators have stationary armature and magnetic field is rotating. I think in a you can compare this with a DC generator. So in a DC generator, what happens? The magnetic flux, that is, poles are constant and armature will be rotating. Here it is quite opposite. So the armature is stationary and magnetic flux is, that is nothing but it is also called as rotating magnetic field. So it is also known as synchronous generator. Coming to the applications, it is used in automobiles and also electric locomotive, marine, radio alternators. That means this can also be used in low band radio frequency transmission and also in electric generation plants. Okay, so all these are applications of alternators. And coming to the classification of alternators, they are mainly classified into two types depending on the design: salient pole type and cylindrical rotor type. I will tell you about these two constructions after. Now we are going to study about the working principle of an alternator. We have already studied the working principle of DC generator. Now I am telling this is an AC generator. So you can see all the similarities between DC generator and AC generator. The working principle of alternator depends on Faraday's laws of electromagnetic induction. Okay, that means what are the requirements of this production of EMF? There are three quantities for the production of EMF. That is, there should be a conductor. Second one is we need a magnetic field, and third one is we need a relative motion between conductor and the magnetic field. Now coming to the working of alternator. For understanding the working of alternator, just I am assuming a single rectangular coil ABCD is placed in between two magnetic poles as shown in this diagram. Okay, so in this first question, you can see that the flux, assume the flux lines are like this, and the conductor is across the flux. That means the flux and the conductor are in parallel. So when they are in parallel, what happens? There is no flux linkages. So when there is no flux linkage, EMF induced is also zero. So according to Faraday's law of electromagnetic induction, only when there is a flux linkage, then only EMF will be induced. So this singleton ABCD is rotating clockwise. Let's say I'm assuming like this. So when it is rotating in clockwise direction after 90 degrees, okay, AB comes in front of South Pole and CD comes in front of North Pole. So according to this, now there is a flux linkage between these two conductors. So due to this magnetic flux linkages, EMF is induced. Hence, the EMF induced is maximum in this second position. Okay. So as per Fleming's right hand rule, the direction of the current will be from A to B. At the same time, CD comes on a north pole. And if we apply the same rule here, now the direction of current will be from C to D as shown in this diagram. Now after it rotates again clockwise direction, that is after 90 degrees, now again the coil will be in vertical position, that is same as our first position, but the conductors are interchanged as compared to the first position. Again, as there is a flux linkages are zero because the conductor and flux are in parallel. Okay, and next, if we, that means here as the flux linkages are zero, EMF induced is also zero. Again, at this position, after it rotates another 90 degrees, again the coil is perpendicular to the flux linkages. Hence, the flux linkages are maximum. So, the flux linkages are maximum and same as in the second position. But the conductors are in opposite direction as compared with the second position. Hence, the EMF induced will also be in the opposite direction. Okay, so you can see here the current is circulating in the turn point from B to A, from A to D, from D to C, and from C to B. So during every full revolution of the turn, the current in the turn gradually reaches its maximum value, reduces to zero, and again comes to negative maximum, and again comes to zero. That means this current is called an alternating current. So the generator which generates alternating current is called as AC generator. So thus an alternating current is produced in this single turn. From this we can understand the working principle of an alternator. So the same we can, you have to draw in your notes by using this diagram. So this is in case 1, the direction, that means this is in position 2 and this is in position 4. So in these both the directions you can observe across the load, the arrow mark is in this direction. That means the arrow marks, if we compare both the cases, the arrow marks are in opposite direction. Hence we can know that the currents flowing in both the cases are in opposite direction. Hence directly I am showing you all the positions like this. So in position 1, as the flux and the conductors are in parallel, EMF induced is 0. In position 2, the flux linkages are maximum, hence the EMF is maximum. And again, in the third position, the EMF is 0. Again, fourth position, the EMF is maximum, but in opposite direction you can see here. And in the last position, again this position is same as that of a first position. Okay, I think you can understand. So this principle is same as the principle of DC generator, but there the only difference is there you have to add, there are a split rings. So because of that split rings, this half, negative half, is converted to positive half. Okay, so you can understand now alternator. Now coming to the construction of an alternator, the main parts are rotor, stator. Okay, the main parts are like this, and you can, I will explain you each one. stator, and rotor. See, you can see the stator is nothing but stator contains slots, and totally the armature winding is wounded on the stator. I think you can observe the difference between DC generator and AC generator. In DC generator, the armature or winding is present in the rotor. So in AC generator, the armature winding is present on the stator and the rotor. So the rotor is here. This is called rotor, and this is called rotor winding or field winding. These are slip rings. Okay. Now coming to the stator, I have already told you the stator is a stationary part of an alternator, and it contains three-phase armature winding. I have already told you this is the outer part of the machine. That means inside the rotor will be there, and outside the stator contains poles, and three-phase armature winding is wound on the stator, and this stator is made of laminations. Okay, and three-phase windings are placed in these slots. Three-phase means that means for each phase there will be 120 degrees phase difference. The armature windings are connected in star, and neutral is connected to ground. You can see the winding of a stator in these diagrams. Next, rotor. The rotor is a rotating part of an alternator. Okay, it carries field winding, which is supplied with DC current through two slip rings by a separate DC source. So here the field winding is supplied by a DC source. The DC source is generally a small generator mounted on the shaft. There are two types of rotors. Depending on these two types of rotors, the alternators are also divided into two types. That is, first one is salient pole type and second one is cylindrical rotor type. Now coming to the salient pole type. Salient pole means the poles are projected outwards. This is called salient pole type. Poles are projected outwards, and non-salient pole or cylindrical type. So the cylindrical type of non-salient type rotors are like this. So you can observe the difference here. So this is non-salient pole type or cylindrical type. This is called salient pole type, where the poles are projected outwards. I think you can understand. This is the field winding in the salient pole type. These circles represents the field winding in the non-salient pole type. So coming to the salient pole type. So in a salient pole type rotor, it has more number of poles. So the rotor diameter is large. It has larger diameter and a small axial length. The prime movers or turbines used are of low speed, such as hydraulic turbines, okay, Pelton wheel. So all these turbines have low speed. They are used for low and medium speed applications. Okay, you can know. And also here also it is mentioned that the speed will be varying from 150 to 600 RPM. So these type of alternators are only used in low and medium speed applications. They are used in hydro power stations, diesel power stations, and are also called hydro alternators. The salient for rotor type is already I have shown you, and the salient pole rotor has non-uniform air gap. Okay, you can see, and they are made. The construction is also strong enough. Okay, so mostly I think you can understand that in salient pole type, the poles are projected. Due to that, they rotate in low speed, so they are used only for medium speed applications. And coming to the cylindrical rotor type, they are also called non-projecting type, or what is the other name? Non-salient pole type. So they have small diameter and large length. Okay. The number of poles used here are 2 to 4. As the poles are minimum, the rotor diameter is small and axial length is larger. The speed of this type ranges from 1500 to 3000 rpm. Okay, I think you can see here. And the turbines or prime movers used here are of high speed, such as steam and gas turbines. These are used in steam stations, steam power stations, and gas power stations. The cylindrical rotor type. is very much used only for high speed applications, and they have some of the advantage, that is it has noiseless. Even though it rotates at very high speeds, the noise is very less. Okay, thank you.